Hey, welcome everybody. We're very pleased to have you at the National Institute of Aerospace. My name is Douglas Stanley. I'm the President and Executive Director of the NIA. We're so very happy to be hosting this for the second cycle and looking forward to follow-on activities. I'd like to welcome particularly all the NASA technologists that are here and members of the entrepreneurial and legal community here, and particularly all of our special guests as the innovators that have brought these exciting ideas to NASA, and hopefully they will be able to transform NASA and benefit them in some way. The National Institute of Aerospace has been around for almost 15 years now. We're about to celebrate our 15th anniversary. We are a graduate education, outreach, and research organization, about $32 million a year of activity between this building and the lab building across the street. Really, we have a big activity in hosting events and doing outreach, and Carla and her team, Robin in particular, I'd like to thank them for putting on this event. And we're in the middle of doing this, the Centennial, the Gala, several VIP events this week, so Harla's head's about to explode, so please be kind to her. But aside from those sorts of activities, we also do a lot of innovative research as well. We have over 50 full-time researchers, about 90% have PhDs. We have 10 to 15 faculty here on site. We have about 30 or 40 students here on site at any given time from member universities. We're a consortium of universities. We were kind of birthed 15 years ago as a strategic partner in NASA Langley, and NASA is still about 60% of our business, but we also do a lot of research for FAA, the Army, other companies such as Airbus and Boeing, we also have a very interesting K through 12 outreach program and do a lot of student competitions nationally. And so but we also have an incubator. And I think, is Daniel here? He was here yesterday. So Daniel Morris runs our technology incubator over here. We have servicing over 20 companies, about half of which are UAS-oriented companies, to try to commercialize technologies of our own and NASA. We generate about 15 invention disclosures a year ourselves from our research staff. And so we're very pleased to have the inventors and economic developers here in the audience, and that's part of our mission as well as the research. With that, I'd like to introduce our speaker to start things off. Dr. Douglas Terrier is the acting chief technologist at NASA headquarters. He serves as the senior leader of that office. In this role, he's the agency's principal advisor and advocate for NASA technology policy and programs. He helps plot the strategic direction of the agency's space technology program. He's responsible for the operation, management, and programs within the Office of Chief Technologist. And the Office of Chief Technologist serves as the NASA administrator's principal advisor and advocate on matters concerning agency-wide technology policy. Prior to his current position, many of you I'm sure know that he was the NASA JSC Chief Technologist, Center Chief Technologist, and he was there the principal advisor to the Center Director for Technology and the Center point of contact for the agency Chief Technologist. He joined NASA in 2003, I'm pleased to say, at the Langley Research Center, where I used to work as well for many years, in the Office of Business Development, where he was responsible for growing and realigning the center's strategic business profile. He got a PhD in aerospace engineering and an MS in mechanical engineering from the University of Texas. And he's also used to work for Lockheed. He completed the Carnegie Mellon Graduate School of Industrial Management program with Lockheed Martin's Institute for Leadership Excellence. He holds patents. He himself is an innovator and creator. He holds patents for his work in aerospace propulsion and has published numerous technical papers. And he also has earned Lockheed Martin's Outstanding Technology Achievement Award on 4 occasions and several NASA Superior Technology Accomplishment Awards and a NASA Leadership Medal. So with that, I'd welcome Douglas to come up here and kick us off.
Thank you very much. Good morning, everybody, and let me add my welcome. This is really an exciting day, and I'm really looking forward to the day's events. So let me begin by thanking a few people, and I probably can't thank everybody, but this is, as you can imagine, this has taken a lot of effort to put this event together. I want to thank our program executive and recognize Kira Blackwell, whose initiative have put this whole iTech very successful effort together. Our support from NIA, and of course, all of our center chief technologists who are do a lot of the heavy lifting, getting us to this stage. And most of all, let me welcome our innovators, our inventors, our investors. We're very pleased to have all of you here, and we're very excited to hear about the great work that you're doing. So this is the second round of our iTech Cycle 2. We had last year a very, very successful effort, and which has resulted in significant progress in technology, and in fact some tangible investment in a couple of the technologies that we showcased and rewarded last year. So we're looking forward to another successful year. It's really cool that this is going on concurrent with the 100th anniversary of NASA, of NACA, I should say, in Langley. Many of you may or may not know the history of how NACA got formed, but this occurred during World War I, when it became evident that the United States had lost its technical lead, its technical edge, after being, claiming to be the first in flight in 1903. By 1915, during the war, if you probably remember, many of our aviators had to borrow Spads and Camels from our allies because we had really lost the edge. Our attention had turned away from innovation to litigation, frankly, primarily between Curtiss and the Wright brothers. So the government recognized that and created the National Advisory Committee on Aeronautics specifically to restart our innovative efforts and to rekindle the United States interest. NASA itself, with the Space Act of '58, was another example of where we'd kind of lost the edge in space, the Soviets. And again, the government recognized that we need to turn our attention back to being leaders and innovators. So we're kind of at one of those points in history again where we are really in a position to restart and re-energize our efforts in innovation, and this is one of the most effective methods we have of doing that. So we look for innovation within the agency, and we look for innovation outside the agency, which today, much of the innovation in our country, around the world, is happening outside the agency. So this is a really, really important part of our overall strategy. So I'm going to spend a couple more minutes this morning before we get started, and I'll try to go quickly, just to give, though I know many of you in the room are quite familiar with our history, but I wanted to set a little bit of context. So I've got a couple slides kind of walk you through where this fits in NASA's overall strategy, where we've been, where we're going. And I'll run through these quickly. So, slide with a lot of data on it, but a couple key things you need to know. NASA is pretty much responsible for discovery and exploration, everything from the surface of Earth to the observable universe. And we do that with a suite of capabilities that range from in the near field and atmospheric flight, aviation assets. We have assets in low Earth orbit, and further afield, we have, of course, we've conducted missions in cislunar space. And then as we look out to the planets in the solar system, we primarily rely on robotic precursor exploration missions to do that. And you can kind of think of this as a continuum of capabilities that both discovers what's out there, and as technology allows, we explore first with robotic surrogates, and then as our technology allows us, we have a wave of human exploration that goes beyond that. But the third stage is very important to recognize, which is a stage of development. So if you think of aviation as kind of the analog, in the 20th century, NASA really led the way with developing the technologies that put America back in the lead in aviation. But those technologies, importantly, have spun off to create what we know today as a global aviation industry that's valued in billions, right? So that's sort of the strategy and the paradigm that we consider applying when we think about exploration broadly. NASA is pushing those boundaries out, providing the technology to enable us to go further and explore. But as we push back the frontiers of knowledge in space, we want that technology to have an impact on Earth. And then we can imagine a bigger ecosystem of innovation and technology that can, in return, benefit NASA, as we're finding today. So in the first half of our history of NASA, first half century, we've obviously landed men on the moon. We've flown 135 shuttle flights. We've built the International Space Station, our orbiting home and laboratory in space. And we've conducted, today, astronauts and researchers on the station are conducting hundreds of experiments that really are aimed to give us the technology to fuel our exploration, but also to provide benefit to a host of industries on Earth. And as I said, we have the benefit of explorers in the virtual sense, our robotic counterparts, particularly in the Science Mission Directorate, both with a host of planetary robotic explorers, as well as the great observatories in space, and those have given us countless developments. One of the things that I think sometimes people fail to recognize, particularly in the press, is that we've learned more in the last decade than we've learned in the history of mankind. A lot of that new science rewriting textbooks being accomplished by our exploration efforts. I like this photograph. This is kind of an interesting, this is obviously a self-portrait from Curiosity on Mars, but the inset there, if you can see, is actually a picture that was from telemetry we got back from Curiosity of the night sky, the evening sky of Mars, and those two dots in the sky are the Earth and the Moon. So it kind of gives you a sense of the perspective, which is the other very important thing about our exploration objectives. It really helps to inform our perspectives about ourselves and where we fit in the universe. We've also had, as I mentioned, a tremendous impact on the aviation industry. That's something that touches each and every one of us every day, and that continues to be a focus for NASA. So all of this has occurred in a relatively short time span, and it's important to recognize that we tend to talk a lot about our experiences and our achievements in space. And this has had a tremendous impact on the Earth as well, particularly on the economy. So we've managed to have an unbroken line of discovery and exploration for over 58 years at NASA. And that largely due to consistent support from both the Congress and the administration of both parties. We've been very fortunate. We continue to have very good support. In return, NASA's investment is returning tremendous value to the economy. So we're looking at, you can read these, but over $300 billion in economic value returned from the aerospace sector, 1.7 million highly skilled jobs, and all of those are producing employment that are on average about 44% higher than the national wages. And we're about 2% of the employment base, and about 13% of manufacturing jobs are in one way or another related to aerospace. So the way ahead, we intend in the next 50 years to have achievements that surpass even the amazing achievements in the last 50 years. And the challenge for us, all of us here today, is how do we maintain that edge? How do we maintain that creativity? And that's why you all are here today. It's one of the ways that we're casting the net as broadly as possible. We recognize that perhaps as we look back at our history, in many areas NASA was uniquely leading in several technology areas. Today, that's not the same story. We have amazing technology developments occurring outside the gates and in other industries and across the world. So we are very, very interested in finding where those technologies can be applied back to NASA and solving the tremendous challenges we have ahead. We're today embarked on developing a commercial infrastructure. Many of you know we have a very successful commercial crew and cargo program. We anticipate low Earth orbit to be completely serviced from commercial providers starting next year. At the same time, we're developing a next generation of human transportation system that'll take us back to the moon, Mars, and into the solar system. And we continue to have an ambitious series of science missions, observatories, and robotic vehicles that will continue to push back the boundaries of knowledge. So this is all enabled both our exploration and, again, the economic impact by innovation. So iTech is, in fact, one of the premier flagship programs that we have that enable us to really reach as far and wide as we can to innovators across the world to enable this to happen. And again, I want to welcome all of you. We're very anxious to hear your presentations. We're looking forward to exciting few days. And thank you all for being here. And I'm really delighted to have you, and I'm really excited about hearing what you have to offer. Let's invent the future together. Thank you.